Hello friends, now we are going to study effect of compensation on surge impedance loading. So the first point, let us take the simple without compensation. The first point is without compensation. So without compensation, we can see that this will be the system L and this will be the system C as of the line. So these are the point. So this is L and this is C. So simply Zs will be equal to under root L by C and surge impedance loading will be equal to Vs square upon Zs. So this will be Zs1 and SIL1. So this is without compensation. Now we are going to see with compensation, that is with shunt capacitor compensation. With shunt capacitor compensation. With shunt capacitor compensation. So guys, when we are doing the shunt capacitor compensation means, let us assume this is system L, this is system C, and we are adding CSH. This is system L, this is system C, this is CSH. So now what we can do is, we can find out, we know that the value of Zs is equal to L upon C. So from here, the compensation is happening in the shunt. So now we will update the shunt. So Y2 will be equal to Y of system plus Y of CSHA. So Y2 means J omega C2 is equal to J omega C plus J omega CSH. So now J omega C2 is equal to J omega C, we have taken common 1 plus CSH upon C. So J omega cancel out. If you want to write, then C2 will be equal to C1 plus KCSH, where KCSH is equal to CSH upon C. So C2 will become this. Now what we can see is, when we will find out the value of Zs2, it will become under root L upon C2. So under root L upon C2 means under root L upon C 1 plus KCSH. So we can also write this under root L upon C means Z as 1 upon under root of 1 plus KCSH. So now coming to here upside, so Zs2 is equal to this. So SIL2 value will be equal to Vs square upon Zs2. So putting the value Vs square upon Zs2 means Zs1 divided by under root means multiplied by 1 plus KCSH. So this will be SIL1 into 1 plus KCSH. So we have this now. So from here we can see that the first point is observe. We can observe this Zs2 is less than Zs1, and second point is SIL2 is less than SIL1, and third point we can see that this improve the transient stability. This will improve the transient stability. This will improve the transient stability. And now this is the shunt capacitor compensation. Now we are going to study the shunt inductor compensation. So in case of shunt inductor compensation means, this is system L, this is system C, and this is compensating element. This is LSH. This is system CC. So now we can modify this admittance, that is Y of 3. This is 3 case. So Y of 3 will be Y of system plus Y of LSH. So ZLSH value will be equal to J into XLSH. So YLSH will be equal to 1 upon means minus j upon xlsh. So putting this value here, we can write the value of y3 will be equal to y plus ylsh means minus of j upon xlsh. So putting the value j omega c3 is equal to j omega c minus j upon omega lsh. So j omega c3 is equal to, taking j omega c common, we can write 1 minus 1 upon omega square lsh into c. So this is, we can write, j omega cancel out, and c3 will be equal to c 1 minus klsh, where klsh value will be equal to 1 upon omega square lsh into c. So this is the value of c3. Now we are going to put the value of c3. So zs3 will be equal to, under root l upon c3. Under root l upon c3 means, under root l upon c3 means c1 minus klsh. So we can write this z as 1 upon under root of 1 minus klsh. In the same way, SIL3 will be equal to Vs square upon Zs3. So putting the value of Vs square upon Zs3 means Zs1 multiplied by 1 minus klsh. So we can simply write SIL of 1 into 1 minus klsh. So simply we can see from these two equations, number 1 is Zs3 is greater than Zs1. Second point is SIL3 is less than SIL of 1. And third, transient stability deteriorate. So now we are going to series capacitor compensation. So now we are going to study series capacitor compensation. So this is system L and this is compensating device CSE, and now this is C, that is system C. So we will now improve in Z. So Z, this is 4. So Z4 will be equal to Z of L plus Z of CSE. So Z of 4 means J omega L4 is equal to J into omega L and minus J into XCSC means 1 upon omega CSE. By taking J omega common, J omega L4 is equal to J omega L common 1 minus 1 upon omega square L into CSE. So this is J omega cancel out, L4 we can write L in bracket 1 minus KCSE. So now putting this value in ZS4 is equal to under root L4 means L 1 minus KCSE upon this C. So this we can write Z as 1 in bracket 1 minus KCSE. So this is ZS4 and SIL4, the opposite of that will be SIL of 1 divided by under root 1 minus KCSE. So 3 points we are considering from here. First is ZS4 is less than ZS1. Second point is SIL of 4 is greater than SIL of 1. And 3 point is transient stability improve. Transient stability improves. So this is the third point. Now one compensation that has been remaining, that is series inductor compensation. So now series inductor compensation means this L of system, the LSE of the compensation, and this is C of the system. So now we will write the fifth point, that is Z 5 will be equal to Z plus ZLSE. Means simply we can write J omega L5 is equal to J omega L plus J omega L SE. So from here we can write J omega L5 is equal to J omega L. We can take common 1 plus LSE upon L. So J omega will be cancelled out, and now simply we can write L5 is equal to L1 plus KLSE. So simply we can write Z as 5 is equal to under root of L5 upon C. So by putting this value we can get Z as 1 under root of 1 plus KLSE. So Z as 5 is equal to Z as 1 under root 1 plus KLSE. So now if I want to write SIL5, that SIL5 will be equal to SIL of, now this SIL5 will be equal to SIL of 1 upon under root 1 plus KLSE. So this is SIL5. So from here we can clearly see that this value will be JS5 will be greater than ZS1, and second point is SIL5 will be less than SIL1, and the third point is transient stability deteriorate. The third point is transient stability deteriorate. So these are the 3 points